Hello, my name is Norbert Kamiński, and today I will present the current status of the firmware update LVFS support for Qubes operating system. Let's start with agenda. At the beginning, I will tell you a few words about firmware update and LVFS. Then I will go to support challenges. Next, I will mention the what is done, and after that I will explain how works downloading and updating firmware process. And at last, but not at least, I will tell you what left to do in this project. So, at the beginning, let's start with the question, who am I? My name is Norbert Kamiński. I'm Junior Embedded Systems Engineer at FreeMDEP. I'm contributing to open source projects like Yocto Layers, Meta PC Engine, Meta Virtualization. I'm interested in embedded Linux, virtualization and containerization, and in bootloaders. Okay, let's start with the standard architecture plan of fwupd LVFS. It could be split into 3 layers. The internet layer contains LVFS and content delivery network. This layer provides firmware and metadata. Whole update process is managed by fwupd manager, which exists in the session layer. The last layer consists of fwupd, which grants communication with the systems and with the device. Okay, Linux vendor firmware service is secure service that can be used by hardware vendors to upload the archives with the firmware. Customers can download metadata about the updates for their devices, and then they can decide to update or not their hardware. The LVFS provides all informations about the firmware. The files are stored in cabinet archives, which contains firmware, metadata, and detached signature of firmware payload. Okay, now we have fwupd manager and firmware update daemon. Firmware update manager is a CLI tool that allows user to perform the update process manually. It takes role of the connector between LVFS and database at the fwupd daemon and fwupd daemon. Okay, the firmware update is a system daemon with dbus interface that can be used by unprivileged clients. The daemon allows user to perform write upgrades and downgrades according to security policy. Okay, let's start with Qubes OS support challenges. We are facing in this project a problem with isolation of Qubes. Admin VM and sysUSB has no internet connection. That means we cannot get metadata directly to the VMs, and that means we have to update the VMs update firmware with data which was downloaded to update VM and then copied to admin VM and sysUSB VM. So another problem is that fwupd must support the firmware update process divided into 3 VMs: update VM, admin VM, and USB VM. Admin VM aka DOM0 now. So, what is done? For now, we have created the architecture plan of the fwupd LVS support for Qubes OS. We've done also the frame of the update process, and we also built the fwupd daemon from the source at the admin VM. Okay. That's my proposal of the architecture plan for Qubes support for fwupd. It contains 3 VMs, and it could be split into 2 parts. First part is update part. That's green blocks. And the second part is update firmware part, and that's red blocks. So let's begin with downloading firmware. Isolation of the admin VM caused that there is no option to download the firmware file, as I said before, and metadata cannot be downloaded directly to DOM0. So we have to download the files in update VM, which is sysfirewall here, and securely we have to securely pass them to admin VM. So the whole process is initiated in the admin VM. By default, that's happen with a script called Qubes DOM0 update. This script initiates whole process and creates the download directory in update VM. Then it runs the fwupd downloads update scripts, and if download process is succeed, the script returns status 0 to Qubes fwupd manager. Okay. Now we will go to firmware update download updates script, which runs in update VM. The script downloads the firmware archive files and performs the third steps of validation. If the script is running with check-only parameter, it will only check available updates for the hardware, and then it will return the results to Qubes DOM0 update. If there is no check-only parameter, the fwupd download updates will download the archives, and then it will securely pass it to DOM0 admin VM. So it will use it for this case qrexec Qubes received updates to copy these files to admin VM. Okay, the qrexec Qubes received updates is just a symbolic link to a Python script. The Python script is responsible for receiving the updates file from the update VM, and that means the script is copying just update files, and then it checks GPG signature, and if everything is alright, it's sending the status 0 to Qubes DOM0 update. If it's not, it raise the exception and write the error logs to proper file. So it just performs the second step of validation. Okay, now let's start with updating firmware. During the updating firmware process, the downloaded archives are installed at hardware. We need two fwupd daemons to perform the update process. First daemon is installed at admin VM, and it provides the updates to non-USB devices, and second daemon is placed on the sysUSB, and it allows us to update hardware connected via USB. So we are coming here to update process. So starting with Qubes fwupd manager, we are taking the information about our hardware from daemons, and we are checking if the version of the downloaded files is higher than a version of firmware that is on the device. So if it's higher, we allow to user to decide if he wants to update this hardware or not, and then it just provides these files to our daemon and providing the update. So at last but not at least, what is to do in our project? So we need to create a custom plugin that will use information from the all VMs, and that will provide proper functionality for our fwupd manager. So we have to also create a Qubes fwupd manager script that will connect the downloading update firmware, downloading and updating firmware process, and then we have to do second step of validation in our downloading process. And I think that's it. Thank you for your attention, and ask the questions.
Yeah, that was very quick. So I would say that we should highlight one important thing. The whole project is sponsored by NLNet Foundation, and we took it after being convinced by Thierry from Insurgo. So thanks Thierry for that, and this is like first step to make fwupd work in Qubes. Richard mentioned that that he is still not sure how we should pronounce fwupd or fwupd or however, but yeah. So any thoughts, Marek? Do you have any thoughts about this design or state of it, or how we should move on? Maybe how this can be used and leveraged in future, or this, like, when we will finish, that's all and we are all happy. What do you think?
Yeah, I think this is quite good design. One minor detail is that Qubes DOM0 update currently focus on just DOM0 packages.
Yeah, I know that.
RPM packages. So this is the same architecture, but actual names probably would be different.
Yeah. Nowadays, I just add the support to existing Qubes DOM0 update script, which allows us to run the fwupd download updates at update VM, and then I'm using the same script, QRSX script, Python, which you are using to obtaining the RPM packages to take in the updates from LVFS.
Okay, but how do you? But then this Qubes receive update script is focused on verifying RPM signatures.
Yeah.
So
Yeah,
you simply add another option, right?
That's a good question because I have trouble with that. I've just created a new method which use QVM run to copy the fwupd files, and then I will check the GPG signature of these files in another way that is now provided to RPM packages.
Okay. Yes. So
that
for
is
the
that to
firmware,
do here. I'm writing about that.
Yes.
That is just under development.
Yes. How those cab archives are signed? Are they signed by OEMs or FW update infrastructure, or how does it work?
That's a good question, but for now I cannot answer for that. Sorry.
Okay. Yeah, so also it would be interesting to see how public keys to verification are distributed.
Okay, I will check that for sure, and I may give information to you.
Okay. One thing to consider would be maybe simplify this a bit, because currently Qubes.0 updates calls into update VM to download packages and then returns packages as a separate qrexec call.
Yes.
Which is, well, it works, but I think it's the asynchronous nature of this somehow makes troubleshooting harder, because you have one call into VM and then another call back to DOM0, and you need to correlate those data. So one idea could be to do a call into a VM to download and return the data inside the same call. I'm not sure if that would be easier, but something to think about.
It would be, I think it would be easier in debug way, because it's now hard to debug the Qubes received updates, because I have to get these exceptions to error files, and then I can just check what is wrong with that, what I'm doing now.
Yes, exactly. That's my issue with Qubes.0 update current design. Other than that, it works pretty well, but this troubleshooting is less than optimal, I would say. Yes.
So we have, Marek, anything else? We have some questions from Richard. I'm now regretting we don't have him here, but as he said, he's just he's busy in daddy mode. Do you have any other questions, or I can switch to some questions from Richard and try to tackle that?
Okay.
I have one more question about this sysUSB handling. How is it? How do you see it? Collecting information about hardware and downloading updates and stuff like that. Do you see it should be separate for each device having VM, like separate for sysUSB, separate for DOM0, and separate for possible some other VMs, or collect all the devices at once, download firmwares, and then distribute them to right VMs?
I think it should be I should collect the devices from our daemons, and then I should show them to the user, and user points what device he wants to update now, and then it will check if updates are available, and then if are available, the user have to agree that he wants to update this device. So it would be one call to fwupd manager for get devices in DOM0, one call to sysusb, and then we are going to update process, downloading update process.
Mm-hmm. Okay. Okay, I think that makes sense. Yeah.
Yeah. So one of the first question from Richard is, what's the timeline for getting things upstream? How to say that? As soon as possible.
Yeah.
But probably we should look also at our internal schedule, and I would not promise anything sooner than in 3 months. So that's our current workload, and like I'm not saying it would be merged; it would be ready to be merged. So that's kind of my point of view. Norbert, if you think this is too challenging,
it's possible. I think it's possible to provide this this solution in 3 months.
Yeah. Second thing is, can you elaborate a bit on the CAP5 validation tool?
Okay. I think we can think about that. You have to just explain in another way what you have on your mind with validation tool here. And maybe I will answer
signature verification or something else.
So the second comment was maybe use JCAD, then it supports GPG, PKCS, etc.
Yeah, that's a good idea. I think I will consider that. Yeah.
Yeah.
First
okay.
First verification will be in. Oh, sorry.
No, continue.
Okay, first verification will be in update VM. That will be this first step when we are downloading that file and we are checking if that file is just right. And the second step of verification would be after copying it to admin VM. Because we don't know if our script isn't corrupted, and we want to check if every file is okay and anyone added anything to it. That's on
that
me
makes sense.
To verify it twice.
Yeah, Marek, I don't know if you see also the chat and the questions in the chat. But the Thierry asking, what about the touched sys GUI? So I assume, like in light of sysusb, like is it another component that will have to connect and ask for updates?
So you mean GUI domain, sys GUI, right?
Yeah, I believe so. The touched sys GUI, I believe he meant GUI domain.
Honestly, I don't see comments on YouTube. I don't know. Oh, here is the link. Okay, I will try. Anyway, in case of GUI, I think currently the only device that is handled there is GPU itself. And firmware for GPU is already distributed as system packages, like so normally there should not be need to any extra integration for that, because GPUs normally don't have persistent storage for own firmware. But having this architecture in place, if there would be more VMs with some devices connected, we can simply use the same method as for sysusb. So I think it should be quite easy, I hope, to add not just one sysUSB, but 4 other domains, if that would be needed.
Yeah, so Thierry mentioned here like all the hardware handling VMs like sysUSB, sysnet, sysGUI. So yeah, this is exactly what you said, Marek. I believe.
Yes, yes.
So right now we don't have any persistent firmware in graphics, as far as I know. Maybe I'm completely. We don't do graphics firmware, but as far as I know, quite a lot of people working on sophisticated graphics support, and there may be some need for GPU firmware in future. I know some designs where GPU cards require special boot firmware and start as a almost separate computer. So I know that this is scary, but definitely this happened there, and there is quite a lot of people working in security, firmware security for graphical environment. So sooner or later, it may be something more sophisticated than we have right now for graphics.
Yes, but currently we already have quite sophisticated firmware for graphics card, simply loaded by the device driver, Linux in this case. So it's some externally loaded firmware is already there, and we already have mechanism to update it. So anyway, I think in the current hardware state, we don't need specifically every update design for graphics hardware, but for graphics firmware. But I think the current design also allows that, if that would be needed in the future.
Okay.
And I have one more question about the, not sure if that one, whatever. What part of this project would be upstreamable to fwupd, and what part would be very specific to Qubes that cannot be upstreamed, if any?
Okay, upstreamable will be, I think, plugin that will allow us to just use this solution with Qubes. But upstream to Qubes is easier because there would be Qubes DOM0 update script. There would be for sure fwupd downloads updates script, which just is taking this stuff from LVFS to our update VM. I have no idea how much work and effort will be with this updating process, because it's hardly in development phase, so it's hard to say. At this moment, I will upstream, I don't know, 3 files or 1,000 line of codes. I cannot answer that question.
Okay. Okay. How does it work for system firmware updating, like UEFI or BIOS? So what is the workflow? If you download the update, what are the next steps? How does it update?
Okay, so we are downloading maybe from the beginning. We are taking the hardware information from the fwupd daemon, and our user is saying that hardware is connected, and that hardware has some version of firmware. Then we are going to Qubes DOM0 update, And here we have two modes. It could be check only, or that could be normal mode. If it's check only, the Qubes DOM0 update is just checking with fwupd download updates if there are possible to download newer firmware from the LVFS, and it's printing that to our user. If that's normal mode, if there is available updates, it's downloaded to our fwupd downloads to our update VM, and then it's passing by QRZEC to DOM0 with our validation script, Qubes received updates. Then we are coming back to our Qubes DOM0 updates. If everything is okay, it returns the exit 0 status to Qubes fwupd manager, and then it starts with updating process. So depends if it's USB device or non-USB device. It calls sysUSB or just staying in DOM0. If it's USB, it calls sysUSB fwupd manager, and it just provide the update to fwupd demo. If it's none, it's the same way, but here. And that's a whole process of the updating.
Okay, but fwupd daemon, or when it applies the update, it in some cases you need some machine reboot and stuff like that, right?
Yeah.
How is it communicated to the user? How does it workflow work at this point?
I think all the informations will be passed to fwupd manager, and there will be plugin which will allow us to just print that to Qubes fwupd manager, and then it will be visible for our user.
Okay.
So reboot required or something like that.
Yeah, reboot required, and then.
So Marek, I'm not sure if you know the capsule update method. The capsule update for UEFI, for example, happens, and then you just prepare everything. It's not like updating. It will happen after reboot. So and I see that Andrew Cooper mentioning that there are some problems in Zen. There are some bugs pending fix. Which can cause problems. He say using UEFI reboot with capsule pending update. If this situation occur, then there are some problems with Zen. I'm not sure. It would be great to get some pointers to that, and maybe we will face those problems when we will implement. So it would be great. So we are in contact with Andrew. We will try to get those what's going on with that. But I assume that Qubes fwupd manager will handle all the like shutting down VMs gently and all that stuff.
Yeah.
And then we'll just reboot and the update will be applied. But I'm not sure what kind of other implications we may have here. I don't know, Marek, do you see any kind of other problems that may happen because of that?
Sorry to interrupt you.
Yeah.
We have one still pending question from Richard in terms of the CAP5 verification. So Richard asked, where's the trust list? It is the list of certificates and keys, either in update VM or DOM0.
Okay. Norbert, can you take that? Or maybe we need Marek support here?
I think we need Marek support here, but the trust list would be in admin VM, aka DOM0 here. That's my opinion.
Yes, that should be the case by design. I have no idea how metadata and specifically public keys are distributed in FWUPD infrastructure. And that was actually why I was asking who signs the updates.
Yeah,
Is it the
I
OEM,
cannot
which
to
means
answer you.
Yeah, if the updates are signed by OEM or firmware vendor, whatever, then it means each device or each device group would need a separate public keys. So there will be quite a lot of those public keys. And we would need some method to distribute that. I hope it is already solved in this FWUPD somehow, but I don't know the current design.
Yeah, Richard is writing
So
here
we'll
that
need to verify that.
Richard is writing here that is shipped in FWPD RPM.
Yeah, so he's just
Okay,
joking.
so that's good.
Just trust the LVFS. Marek, just trust the LVFS.
It's better to trust LVFS than closed firmware.
Yeah, so definitely there are a couple of things. Signing is on LVFS side. So LVFS provides signature in the package, and yeah, so this is done by any chain required for a given platform. So, for example, I'm not saying anything specific, so Richard would be the expert to saying specific things, but let's say we have some vendor that provides hardware. They may have some associated provider of BIOS, if we're talking about BIOS, and then I assume both the vendor certifies that the BIOS provided that by this vendor is good to go. So we did that with LibreTrend box. So this was done when we enabled flash ROM support inside FWPD. And I believe this is the same thing can be done for other platforms. At some point, we discussed with Richard ability to have various flavors of platform. Let's say we have this famous X230 ThinkPads, yeah, which may have coreboot, but of course, like maybe a vendor of that laptop do not like to endorse some custom firmware, but we would like FWPD LVFS infrastructure to support those open source firmwares. And I know that Richard thinking about that, and probably in the future we will have ability to also support those other platforms through open source firmware. And of course, then you have to trust the vendor who provides this custom new firmware. But probably you will change how your hardware is identified. And just to say, like, for example, this is X230-coreboot, yeah, or -3MDEP coreboot, whatever coreboot, yeah. And then the signature will be verified for this given hardware, this flavor of hardware.
Yeah, that makes sense. Actually, we're talking about open source firmwares. Is there any support in the infrastructure for reproducible builds, like some distribution for information that this firmware was reproduced by those three third-party rebuilders or something like that? Because I think
very cool. This is very cool feature request.
Yeah.
Timeless,
so it's not there yet.
Timeless coreboot builds are reproducible, but I think not each payload can be reproducible. I remember we had problems with iPXE reproducible builds because it incorporated some random build ID or something like that in the runtime. So each iPXE build was different. But the coreboot itself, when built timeless, is reproducible.
Yes, I know. Also, I think heads builds are also reproducible already. So that's a good thing. But for the complete picture, we would also need the firmware updating method to actually verify this. I'm not necessarily saying that each user need to build its own firmware, but some method for distributing proofs of reproducibility would be nice addition. But yeah, that's
So is there
probably a product for some future.
Yeah, definitely, Marek. That's great feature request, and I know a couple of things that I know that Richard kind of introduced security checks through chipsec and probably other means. So that's kind of like additional feature that probably will happen. And there are some checks when you have like tags or labels that okay, this works. This was validated. That was validated, and it's good because of these measures. And definitely, it can be another batch which saying it was reproduced by this or that service, and you can check the results of the build, so you can confirm that that whatever was built is the same. But I don't know, is there any service that already provides proofs of reproducibility?
I don't know the specific one. There is quite active discussion about it in Debian. There is also an infrastructure to verify reproducibility, the test reproducibility.org. It's a Jenkins instance which builds a lot of software twice in different environment and verify that. But the actual delivering result of those tests is still in a design phase. There are, I think, 2 or 3 proposals how to deliver these results, and yeah, this is some ongoing work.
Yeah, definitely, this will be very interesting. Not only for LVFS. There are, like, I believe many projects can benefit from that. Right? For example, so as I said, 3MDeb provides, for example, PC Engine's coreboot distribution, and we always publish signed hashes of the firmware. But if there will be like third-party service, even like paid one, which kind of provides this and it builds its trust in community, that would be very interesting to have.
Yep, definitely.
The consensus, like this is like blockchain cryptocurrency stuff. This consensus mechanism, like 5 services.
Oh,
This is Daniel comment. Like this is my idea based on Daniel comment. Like. Yeah, triggers. That's correct. Like we always have to have blockchain, cryptocurrency, something. Otherwise, it would not be. There will be not enough hype. And we have to take care of this video. So search engine optimization. No matter what, have to register that. But anyway, this is like couple services confirming that what someone claims it's true, it is really true, would be of some benefit. Definitely this cannot be like, this have to be economically feasible, because if it's too much, then definitely it's like just hype, not the real benefit to the community and to the vendors and providers.
Yes,
okay.
Yes. So the current state, yeah, okay.
Yeah, please, Marek, we still have a lot of time.
Yeah. For the reproducibility, there is some proof of concept implementation for Debian packages. Like you can install add-on for apt, and then apt, when you install any package, it will query a service to list of signed information that this package was reproduced by A, B, and C. And you can define policy who you require the package to be reproduced, and it will refuse to install package if it was not reproduced by defined third-party services. So it's really cool, but it's just proof of concept.
Okay. So I see that despite the presentation was quite short, we have a lot of discussion and it's a lot of activity on chat. Richard explained a little bit here about the kind of the pipeline of how various dependencies and how the firmware is delivered to the end user. So he said that it's like silicon vendor or independent silicon vendor. I think the I means independent, but I don't know like if it's really independent, hard to say. Then we have ODM, so device manufacturer, then we have equipment manufacturer, and then we have user. And this is kind of, I believe it's reflected in LVFS infrastructure. Yeah, so that's probably some additional information to the previous discussion. And sure, Frederick.
So just a question, Norbert, about the integration of your update pipeline in DOM0.
Yeah.
Have you tried to move this part only into another admin VM?
No, I have not tried that, but I think I will consider that because now it's a little problematic. Yeah, I think that would be a good idea.
Okay.
Do
you see any limitation or issue about that?
Once again?
You still need to access /boot for UEFI firmware update.
Yeah, I need to.
At least. So that part definitely need to be running in DOM0.
Okay.
But a call can be made to request the needed information. I don't know, maybe some way to restrict access somehow. I don't know.
Yeah.
Is it the part the call to update VM already?
No, that's not the part of update VM already.
Okay.
Okay.
So nice.
So I don't know, like maybe we can smoothly go through the Ask Me Anything in area of Qubes OS future and related stuff like to updates, to AMD, maybe some questions like let's like if anyone listening this, I see 36 people here and probably more kind of playing that.
So make a little technical break and then we'll be back in just 30 seconds or 2 minutes.
Okay. So let's take 30 seconds technical break and yeah.
So.
Okay, see you soon.